Hello everyone, this is Wilson. Let's talk about this limit problem here. We have this function 2x plus 4 over x minus 4 over x, and so that's a complex fraction. And we are going to let x approach negative 2 and see what this function is approaching to. And so every time we encounter a limit problem like this, we are going to try a direct substitution and see if we are getting an answer. So let's get started. So we are going to start by writing down the form of the function, and then we are going to change the x into a blank so that we can actually just plug in the number in there and see what's going on. So right now, if we are plugging in the negative 2 into all the blanks that we see right here, all the x's, right? So it's 2 times negative 2 plus 4, and then we also have a negative 2 minus 4 over negative 2. And let's see what's going on here when we try to compute this limit. So we know that 2 times negative 2 is what? It's negative 4 plus negative 4. So that's what the numerator looks like. And then what about the denominator? Let's see. So we have negative 2, and then now we have 4 over negative 2. That's negative 2. So we have minus negative 2. Do you see what's going on here? If we try to compute the top, we are going to be getting 0, right? And then at the bottom, it's actually approaching the same thing. As you can see here, that's negative 2 minus negative 2, so that's also approaching 0. Okay, so we are getting an indeterminate form of 0 over 0. Again, that's we don't know what that is approaching to. We need to do some work to this expression. Okay, so we are going to actually start the problem right now, and we want to see what we can do. Because this is a complex fraction, one thing that we can do is that we can try to, there are two ways to do it. One way is to get the common denominator for this, and then we can do the division. Another way is to get rid of the fraction inside the fraction. Okay, so I think the easy way in general is to multiply the numerator and the denominator by x so that we can get rid of this fraction here. Yeah, we are going to get rid of the denominator, this denominator inside this denominator. And we can do that, right? We can do that. We can multiply the top and the bottom by x. It's really because x is approaching negative 2, so we're basically just multiplying the whole fraction by 1. So we are not changing the problem. Okay, so let's do that. So we have 2x plus 4, right? And then in the denominator, we have that x minus 4 over x. And so what we need to do here is that we are going to multiply the top and the bottom by just x. Okay, so that's our first step. And so from here, we are going to be getting what? We are going to be getting a new numerator. So that's x times 2x plus 4. Just know that even though we didn't have parentheses originally for this expression, but because we are multiplying both terms by the x, right? We are multiplying the whole numerator by the x. We need, when we put them together, we need a pair of parentheses to surround the 2x plus 4. Because eventually we got to distribute this x to the 2x and the 4. Same thing at the bottom, right? So make sure that you put parentheses also for the denominator. So we are getting this thing right here. So x times, what is that? That's going to be x minus 4 over x. Okay, so from there, so we shouldn't be getting lost in the process, right? Don't try to cancel the x right here because that's what we did, right, at the beginning. So if you cancel the x, we get back to the original problem. So we're not going to be getting anywhere. So make sure that you now start distributing the x and see if good things will happen. So let's do that. So we are going to be getting what? In the numerator, we distribute, right? So distribute right here. Then we are going to be getting 2x squared and then plus 4x. Okay, so that's... And then what do we get at the bottom? We are going to be getting x squared minus... Now, here comes a good thing, right? X times 4 over x, the x's will get canceled. So we are just getting just 4. Now, it becomes a typical rational function that we are trying to find the limit of. And one thing that we need to realize is that when you plug in the negative 2 in there, it's still approaching 0 over 0. So what we need to do right now is to try to factor the top and factor the bottom and see if there is anything that will get canceled. So let's do that. Okay, so if we are factoring the numerator, we are going to be just factoring out the GCF, the greatest common factor. We can see that the 2 will go into both terms, and then also there is an x that goes into both terms, right? So we can factor out 2x from here. So just point out one thing to you is that we distributed the x, and then now we are factoring out the x. We are actually going backward, but we are actually also pulling out the 2. So we could have done it right here. But for the bottom part, it's actually necessary because it's so you know that we don't want this fraction inside the fraction anymore. So that's actually an important step for us to turn it into a different expression. So right now, this part right here, we did extra work, but that's okay, right? We are going backward, but then now we did a little bit more. We factor the 2. Okay, so we are going to be getting x plus 2, as you can see here. And then now what about the bottom? So you know that the bottom, it's the difference of 2 squares. So we can factor that as x plus 2, x minus 2. And let me rewrite that. So x plus 2, and then x minus 2. Okay, so we can see that there was an x plus 2 at the top and an x plus 2 at the bottom. And when x is approaching negative 2, that x plus 2, both factors, are approaching 0. And it's really just those factors that are causing the form of 0 over 0. Now, what we can do is to cancel them, because when x is approaching negative 2, we are actually not getting an actual 0. It's just the number is approaching 0. So we can cancel them. We can divide by the top and the bottom by the non-zero number. And so if we do that, then we are going to be getting 2x over, what do we get at the bottom? X minus 2. So we're getting x minus 2 at the bottom now. Okay, so can we substitute the negative 2 in there? Yes, we can, right? So we are going to write it as 2 times x. And then in the denominator, it's something minus the 2. And now we plug in the negative 2 in there. And then we can reach the final answer. What do we get here? We are going to get negative 4 in the numerator. Okay, nice. And then what about the denominator? Also negative 4. So that's an easy number, right? Which is 1. And so that's easy to calculate. And so we're done with this problem. So as you can see here, for this kind of limit problems, if you get a complex fraction and you're trying to find the limit of this complex fraction, one way to do it is that you can multiply the top and the bottom by whatever that can remove the fraction in there, whatever that can cancel out the denominators that we have in this big fraction, and then we'll turn it into a usually a typical rational function, and then we can factor. Another way that we can do this is that we can get the common denominator and then try to actually do the division from there. But then this way may be easier and more efficient. Okay, so that's it for this problem. If you like my video, please subscribe my channel and then leave me some comment, give me a like, and then also please share my videos to other people. And then also please check out my other videos in this channel. Thank you for watching.